I was a good boy. I cleaned all my dishes, and now I'm back to weigh out my crystallized sulfanilamide. I'm going to take the crystals off of the filter paper and put it on this watch glass, a different watch glass. So I need to get the weight of this if I want to know the yield. So I'll take initially though, on the back side, the side that the crystals won't touch, I'll put the, I'll label it. Maybe I should be writing backwards. Run out of room here. Sulfanilamide. I'll try to do my initials backwards. M, F. Oh, the S is hard. S. I think that's it. And today's date 2/23/21. There we go. Okay, so I've got it all labeled. I'll go get the weight. I'll go record the weight of it. And then we'll scrape those crystals over it. So yeah, MFS came out good. This is backwards, but it's okay. Okay, let's go weigh it. So what do I want to use? Do I want to use the top loading balance or this other microgram balance? Doesn't matter that much. Oh, we'll go microgram. Get some more significant figures. Oh wait, before I do it, I need to zero this. This was zeroed for the Erlenmeyer flask we crystallized in. Looking good. Looks good. Right in there. And we are coming in at 73.3025. Yeah, 73.3025. Now to transfer my crystals over, I'm going to do this by, actually I'm going to switch sides with this. I'm going to grab the filter paper with some forceps or tweezers and then carefully push those onto the watch glass. I don't want to really scrape the paper too much because I don't want to get paper fibers in here, filter paper fibers. These filter papers are pretty resistant to having fibers come off of them. I'll still do my best to be careful with it. If I tap it maybe a little bit, that might help. Oops. Yeah, there we go. A little bit of scratches, not too much. Okay, that's the majority of it. And then I might have a little bit on this that came off on the filter paper from the first watch glass. Oh, that's good enough. Okay, so as I said before, crystallization's never 100% yield. There's always going to be some loss. But let's go ahead and see what we got right here. Go look at how much this weighs now. What's our yield? We started with about 0.3 grams, and it was 95% pure. So we should have a little less than 0.3 grams if we were 100% yield, but we shouldn't be 100% yield because the crystallizations are never 100%. Okay, so here we have it. We got 73.4885. Wait, let's just keep waiting. We keep getting a better and better yield. The scale sometimes can be funky. I'm gonna go with, I don't know. Sometimes these scales can build up static electricity. Let's see what that comes out now. 73.48. I'm gonna go 4890. These crystals are looking so nice. I want to check out some of them under our cell phone microscope. So a few years back, I saw a video on YouTube of someone making one of these cell phone microscopes. They're pretty cool, and they're just simple to make. You have right here just a little pen light, LED light. And the button to turn on is underneath, so I got the light on there, right? And then up here, our lens is just from a laser pointer. So this one was from a laser pointer at the dollar store. So you buy the laser pointer for $1 at the dollar store, take the lens out, and you put it in this plexiglass? Plastic. I don't know what, is this plexiglass? I think so. And then we can use this as a microscope. Let me show you how it works. First, I'll put some of the crystals on this cover slip. Okay, let me see if I can get some nice crystals out of here. Maybe that big long one there. There we go. And then I will take this and I'll slide it underneath the laser pointer magnifying lens. Okay, and then I could turn the light on to get some light behind it, but I like to sometimes try it without the light, see how it looks first before I try the light. Okay, here we go. I'm coming into the lens, laser pointer magnifying glass. Let's see, come on, zoom in on that. It wasn't working so good without the light, the backlight, so I put on that light, and now let's check it out. All right, that's looking pretty good. So that's some nice looking crystals, huh? Can zoom in a bit more, maybe move it over a little bit. Let's see if I add a piece of paper towel over the light source, the backlighting, see if that changes it. Oh yeah, I kind of like that. Some pretty nice looking crystals, right? Let me try to put some more on there. I feel like they can look better than this. I'm gonna get more and see if more, like a bigger pile, looks more interesting. Okay, now I got a lot. Yeah, that looks pretty. Oh, look at that, much better. Maybe it was the it was the crystals that were low or weren't focusing. They were too far away. Now they're closer. Isn't that cool looking? Reminds me of like Superman's Ice Palace or something. So here's our crystallized sulfanilamide. Looks very pure to me, doesn't it? Looks like it's ready to go slow down some bacterial growth, some bad bacterial growth. Look at that. Cool, huh? So this is what I did with the backlighting. I put paper towel over just to kind of make it not so bright. It seemed to work. If you've used microscopes, you've probably seen similar type of things. Now I'm going to record the melting point of our impure sulfanilamide as well as the crystallized sulfanilamide that we crystallized to see if we have evidence that we did make it more pure. We're going to use the Meltemp 2 by Laboratory Devices USA. So this is a pretty simple process. First thing you need to do is get a little bit of your solid, the impure sulfanilamide in this case, into a capillary tube. And this capillary tube, it's going to be the melting point tube here. It's going to be open on one end. Let's see if we can. Tube is open on one end and closed on the other. So it's a really thin test tube. What we'll do is we'll get a little bit of this impure solid into the opened end and then make it go down to the bottom of the capillary tube to get a melting point. So here's how we get it. Easy way to get it, when you have a nice fine powder like this, you just stick your opened end of your capillary tube into the powder and it might grab just enough for you. You don't need much at all. Yeah, I think I got some in there. That looks good. And then I turn the capillary tube over and I tap it on the counter. There it goes. I saw it. So now we have some sample in the bottom of our closed end of our capillary tube. There it is. Come on, buddy. There it is. And we're going to melt that slowly and monitor when it just starts to melt and then when it's completely clear and liquid. And we'll record that as the melting point range. The melt temp works this way. There's a thermometer in here, just a regular mercury thermometer, and it gets held here where the temperature of the metal around the thermometer is going to be equal to the temperature that your sample is going to be at inside of here. And how you heat it up is you first just turn it on. And when you turn it on, it'll not only start heating, but a light will turn on. So you'll see when I hit the on switch, that light turns on. And there's a magnifying glass. We're going to be able to look into this magnifying glass and see our sample within there magnified. Watch for it to melt. Looks like it's got a little something on the outside. Let's see if I can clean it up. So I have it on, and this, I actually switched to another melt temp. This one's got a cleaner magnifying glass. We'll be able to look in there and watch our sample melt. And this dial here adjusts how hot, how fast we heat the sample. When it's at 0, it's heating very slow. 1, it's heating faster. Or that's a, yeah, 1, 2, 3. The higher I have this dial, the faster the temperature will rise. And when I say the temperature rise, we'll see it rise right here on the thermometer. When you have your sample in here, you don't want it to heat too quickly through the melting point range, because if it, let's say you're heating it up and the melting point's like 100 degrees Celsius, you're looking at the sample through the magnifying glass, you see it start to melt, you come up here and you see, oh, it's at 100. It started to melt at 100. Write that down, right? That's 200. Say you see it at 100, you write it down. And then you go back to see, okay, now let me wait till it becomes clear liquid. And then all of a sudden it's clear liquid. You come back up and it's at 150. You're like, wait, I started at 100, it's already 150? Because you were heating it too quickly. It heated right through your melting point range very quickly. You want it to heat up slower through the melting point range so that you have time to like see it start to melt, record that temperature, see it when it just becomes liquid, quickly record that temperature, and that's your range. You don't want to heat it so slow though that it takes you all day to do this. So what I like to do is, if I know what the compound is, like I know what sulfanilamide is, I'll look up the melting point online. And whatever it says, I'll turn the dial up and heat fast to about maybe 20 degrees below that temperature. And then I'll turn it back slower to slow it down so it goes slowly through the melting point range. So let's try that. I'm going to look up the melting point of sulfanilamide first. I looked up the melting point range of sulfanilamide. According to Wikipedia, it's 165 degrees Celsius, so we're expecting something around there. So what I'm going to do is I'm going to put my melting point tube with my sample in this little slot behind the magnifying glass. I'll drop that in, and then when I look in the magnifying glass, you'll be able to see the sample in there. We should. Yep, there it is. Let's see, is it focusing? If I go right up to it, that will help. Yeah, there it is. So now we're going to watch that as we heat it. Right now, I have it heating at 0, so it's heating very slowly. And I'm only at about 30 degrees Celsius. So I'm going to speed this up. I'm going to turn the dial to say like 5 and see how it goes to speed up the heating. Okay, I'm up at 30 degrees Celsius. It's rising pretty quickly. I'm going to speed it up a little more. I'm going to put it at like, what do I got it there? About 8. Let's say I put it at 8. Watch my thermometer. It's rising. It's at 40. Maybe when I get to about 120 or so, maybe I'll slow it down. Let's look inside here, see if it still looks like it's solid, like it should. Yep, it's looking like solid to me. Temperature's still rising. We're at 110. I think I'm going to slow it down a bit now. Let's bring it to maybe 3. And then we're back. Now we're at like 120. Let's look inside, see how it looks. Still looking like solid. And I'll look up off camera. We're at 130. The rise in temperature did slow a little. About 135. Almost to 140. No melting yet. What I'm looking for is like a bead of liquid, a little droplet, the original, and I'll call that my the the start of my melting point range. The thermometer temperature was dropping, so I had to turn the dial back up, and now it's at 7 again. It's up higher. And so now I'm up at what temperature here? It looks like we're at about 58 or so. Let's look in here. Let's see. Yeah. Oh, I'm seeing some drops. Let me see if I can show you. So let's call the start of the melting point here. Goodness gracious, it does not want to focus for us. And that we'll call it like 158. And now it's liquid, and it's at 162. So let's say it's 158 to 162. It's still rising, but it was already fully liquid. I'm going to try to pick a picture of the liquid. The video didn't seem to work very good. Now I'm going to take some of my pure crystals, my nice crystals. I'm going to get the melting point of them. The way I'm going to do it, I need to crush them up a bit because they're too needly to fit inside of a capillary tube. I could use a mortar and pestle, or I could just use the bottom of a test tube and a watch glass. So I'll kind of grind this up. The thing that's nice about melting points, is you don't need a lot of sample to do a melting point. If you're making something and it's precious, if you only need a very small amount to test it, that's nice. Or if the test doesn't destroy it, but this test kind of destroys it. We just get rid of the small amount of sample that we used to test on. So it's what we call an analytical technique, not a preparative. Analytical technique, you take a small amount of sample, get data for it, and then destroy, like it's destroyed. Where preparative would mean then after you're done, you would have it to use again. This is more analytical, so it's good to have analytical techniques that require very little sample. So yeah, let's see if we can get that powdery crystal now into the capillary tube. I have another capillary tube. Once again, we've got our open end and a closed end. And we want to get some sample into the open end, so I'm going to stick this into my powder. Let's see if I can get a little bit on there. You don't need much at all, just a little bit. Let's see if this will work. Tap it on the counter. Whoops. Did I get some down there? I got just a tiny amount. That could work actually, but I'm gonna probably add a little more. So as you can see, just a little bit in the bottom there. That is enough. So you barely need anything for this one. Let's see if I can get a little more. I turned off the melt temp after using it to record the melting point range of the impure sulfanilamide, and it's been cooling. It's down to 120, so I think it's cool enough for me to add my crystallized sample. So I'll add that into the slot right in the back here. There we go. Oh, I still had my other one in there. This was the original, the impure sulfanilamide. So I've got my crystallized in there. It's not on currently, so I need to turn it back on. It's on. I'm going to turn the dial up to like 7, maybe 6, and see if I can watch it slowly melt. So when I come over here, if we look carefully, let's see if I can zoom in and get it to focus. We'll see that it's not melted yet. There it is. Yeah, it's just a little bit of crystals at the very bottom, not melted yet. And it should melt at a higher temperature than the last impure sample, and it should melt at a narrower range. So the last one melted, the impure melted for me 158 to 162 degrees Celsius. So that's got a melting point range of 4 degrees Celsius. So let's see if this one has a tighter melting point range. So let's watch it carefully here, and I'm going to monitor the temperature. I'm up to 120 degrees Celsius now. All right. Oh, it just melted from about 160 to 162.